Welcome to your second video lesson on complex conversions and dimensional analysis. Up to this point, we have focused on the metric system, some of the prefixes, significant figures, scientific notation, and the last lesson we introduced simple conversions. And complex conversions and dimensional analysis are basically an extended version of a simple conversion. Obviously, just by the title, they're a little more complicated, a little more complex, but it's something that we will use quite a bit in this class, so it's something that we need to do. And lastly, dimensional analysis is a helpful tool as we go through this class on looking at equations and determining whether a physics equation is valid or not, and it's also a way for us to determine different units for different things. So starting off with complex conversions, there are really three main types of complex conversions that we can have, and really they are based off of simple conversions. Simple conversions, we simply looked at taking a numerator, a certain unit, and converting it to another unit within the numerator. The first type of complex conversion we have is taking a simple conversion and doing a little extra step, and that is by taking both a numerator and a denominator and changing the units of both of those. A good example would be like taking miles per hour and converting that to something like meters per second. Notice both the numerator and the denominator are changing. Okay. Second type of complex conversion we have, and these ones get a little difficult, but something that we will use quite a bit, is taking something like an area or a volume and converting those. An example here, area. Think of like an area of a rectangle as a base times a base, or length times a length. So that'd be taking like a meter squared, which is a meter times a meter, and converting that to, say, a centimeter squared. Okay, so just converting, it's almost like converting doing a simple conversion from meters to centimeters, but notice the thing that's going to make it or give us a little issue is the square. Okay, and then lastly is a combination of both numbers 1 and 2. Is changing both the numerator and denominator, but also changing from a square to a square or a cube to a cube. So doing both 1 and 2. So let's start with the first example, and I kind of hinted at this in the previous slide, is going from miles per hour to meters per second. So notice, if we looked at a simple conversion, that would be like converting miles to meters, as well as hours to second. But notice we are taking both the numerator and the denominator and converting them to different units, talking about the same length, or same dimension. So miles, length, we are going to change to a different unit of length of a meter. An hour, a measurement of time, we are changing to a different measurement of time known as seconds. So notice we are converting each within the same dimension. So we're not going from, let's say, a length to time, because that would make no sense at all. So, starting off, we're going to do the same process we did with simple conversions. Now, with simple conversions, I showed you the parentheses method. I'm going to do the other method of using the matrix system or the bracket system. Okay, so I'm going to start off with what I'm given. Now, I'm given 45 miles, okay, per hour. Now, per hour, this symbol here, per hour, represents that you're dividing. Okay, so it's 45 miles divided by hours. Now, when I say per hour, that means for every 1 hour. So I'm going 45 miles every 1 hour. So you can write your denominator as 1. Okay? Now, this method, the bracket method, when doing both numerator and denominator, makes it a little easier to see. So, let's start off with the numerator. Okay? Since I'm changing both length and time to different units, I'm going to do one at a time. So really what we're doing is we're doing two simple conversions within one problem. That's making it a little more complex. Okay, so I'm going to start off with 45 miles, and I'm going to convert that to meters. So 45 miles. Now using your chart, first thing I want to do is I'm going to go from miles to meters. Okay, again, just like we talked about in simple conversions, you are going in this problem miles to meters. Miles is the U.S. system of measurements. Meters is the metric system of measurements. So I'm changing systems. So when looking at this problem, the first thing I need to do, if I'm going from the US to metric, I need to look at my US to metric conversions. And miles and meters are both units of length. Okay, so I'm going to look at my length. So looking at it, some of the things I have on your chart, you have 1 yard is 0.91 meters, and 1 inch is 2.54 centimeters. Now I want to go to meters. So the one that would make a little more sense is to go from yards to meters. Okay? So my goal to get to meters is I'm going to use the US conversion of yards to meters. Okay? Meaning, first thing I need to do is I need to go from miles to yards. So within your US conversions under length, you want to look at miles and see how you get to yards. Okay? So in your conversions, you should see that you have the conversions of miles to yards, where 1 mile is 1,760 yards. So that's the conversion I'm going to use to get from miles to yards. Again, how do I cancel that out? Well, in a fraction, if you want to cancel something out, let's say r, you need r in both the numerator and denominator. So if I want to get rid of miles, miles right now is in the numerator. So I need to get rid of it by placing it in the denominator. Therefore, miles will cancel out. And I want to go from miles to yards. Okay? So here miles would cancel out. Now what is my conversion? Conversion is 1 mile is 1,760 yards. Okay? So now, if you really look at your units, miles cancel out, and I am now left with yards per hour. Okay? Now the next step is to take that yards and go to meters. So looking at your US to metric conversion, we said that we're going to use the yards to meter conversion, where our conversion is that 1 yard is going to be equal to 0.91 meters. And again, why I place yard in the denominator is because I want yards to cancel out. So notice if I take these, yards divided by yards cancels out. And now what I am left with is meters in the numerator, and hours I have not touched yet is still in the denominator. So really, my units are meters per hour. And I want to get to meters per second. So I'm going to do that process and go from hours to seconds. Now there's a one-step process you can do, I'll show you in a second, but we can do this in 2 steps. Okay? Hours, now this is backwards, hours is now in the denominator. So to cancel out hours, I need to place it in the numerator. I need to multiply by hours. Hours divided by hours will cancel out. Okay, so I have hours in the numerator. That's going to allow the hours to cancel out. Now if I want to get to seconds, okay, if you think of time, you go hours, minutes, seconds. So let's first go from hours to minutes. Okay, so hours, minutes. Hopefully you know this. Are there more hours in a minute or more minutes in an hour? Now, obviously minutes in an hour. So within 1 hour, I have 60 minutes. Okay, so now my hours have canceled out here and here, and I am now left with minutes in the denominator. If I look at what's not canceled out, meters still remains, minutes still remains. So my units are meters divided by minutes. And the last thing I want to do is get from minutes to seconds. So again, minutes is in the denominator. So to get rid of it, I need minutes in the numerator. Okay? And I want to go to seconds. Seconds in the denominator. So I'm going to take minutes and put seconds in the denominator. So how many minutes are in a second, or seconds in a minute? Well, obviously within 1 minute, there's 60 seconds. Okay? So that's going to allow minutes to cancel out. And what I am left with now, if you look at all your units, is meters in the numerator, that is yet to cancel with anything up here, and seconds in the denominator. So if you look at that, that's meters divided by a second, or a meter per second. Okay, so now I am all done with the process. And now to solve this problem, all you have to do is take all the numerators, 45, 1760, 0.91, multiply those across, and then divide by everything that's in the denominator. Okay, so punching this into your calculator, you are going to take 45 times 1760 times 0.91, and if you want, times 1 times 1, If you hit enter, that's going to give you 72,072. And then looking at my denominator, I have 60 and 60. So I'm going to take that answer and divide by 60 and divide by 60 again. And what that's going to give you is 20.02 meters per second. And that is my answer. So what I've done is I have converted both the numerator and denominator into different units of length and time respectively. Okay, so I've now expressed 45 miles per hour as 20.02 meters per second. Okay, that number is relatively the same, it's just talking about different units. Alright, our next example, similar type of problem, similar type thing. We are going now from 500 liters per hour, and I want to get to fluid ounces per second. So if we look at our units, liters to fluid ounces. Liters is metric, fluid ounces is US. Hours to seconds, that's time. One thing I don't know if I mentioned, but time does not change from the US system to metric. Okay, time is universal, it doesn't matter. We don't have different measurements for time in each one, so that's always going to be the same. So that's kind of an easy thing. So going through the same process, I'm going to start off again with 500 liters per hour. Okay, per hour, again that's representing divided by 1 hour. So I'm going to go through the same process. Okay, so starting with liters, I want to go to liters to fluid ounces. Okay, well what is a liter? Well, a liter is a volume unit. Okay, unit of volume. So I want to go from liters and I want to get to the metric to US. So looking at your US to metric conversions, you have the conversion of 1 gallon is equal to 3.78 liters. So now I'm going from liters to gallons. So starting with liters, I need to get to, in order to get the fluid ounces, I need to first get from liters to gallons. So I'm going to use that conversion. The conversion says that for every liter, okay, or for every gallon, you have 3.78 liters. In order to cancel out liters, I need to place liters in the denominator. And I'm going to put gallons up top. So I have 1 gallon is equal to 3.78 liters. Here, liters will cancel out, and I'm left with gallons per hour. Gallons per hour. Now I have gallons. That's the US system. Under volume again, I can go from gallons to fluid ounces. Now here's going to be a couple extra steps here, because notice on your chart I don't give you a conversion simply from gallons to fluid ounces. So you're going to have to do a couple steps. Okay? First one I give you is from gallons to quarts. Okay? So 1 gallon is going to be equal to 4 quarts. Okay, again, I'm canceling out gallons, so I need it in the numerator and denominator, and I'm left with quarts per hour. From quarts, in order to get to fluid ounces, I need to go to pints. So 1 quart, again, trying to cancel it out, is going to be equal to 2 pints. Okay? Now I have pints per hour. And then once I have 2 pints, then I can use the conversion from pints to ounces, and I have 1 pint is equal to 20 fluid ounces. Pints cancel, and now I am left with, if you think of your units, fluid ounces per hour. And I want to get from fluid ounces to seconds, or per second. So the last thing I need to do is convert hours to seconds. Now, up above I gave you, we did the same conversion from hours to seconds, where I did hours to minutes, and then minutes to seconds. Okay, shown here. Now I'm going to give you right now a quicker step. When you want to go to hours, 1 hour is 60 minutes, and 1 minute is 60 seconds. So if you look at this process, there's a simple conversion to go from hours to seconds, where 1 hour is 60 times 60, so 3,600 seconds. It's a simple way to go from hours to seconds, kind of shortens it up. So I'm going to use that conversion here. Again, hours is in the denominator, so to get rid of it, I need to place hours in the numerator. In my answer, I need seconds in the denominator. So I'm going to divide by seconds. So I have 1 hour divided by 3,600 seconds. Hours now, beginning, cancels out there. And if you look at all your units, liters canceled, gallons canceled, quarts canceled, pints, I'm left with fluid ounces, and hours canceled, and I'm left with seconds. So I am left with fluid ounces per second. Okay? Now to solve this, do the same process. All your answers above should multiply across, and then you're going to divide by all the things in the denominator. So you're going to multiply all these, divide by all these. Okay? So, I take 500 times 1 times 4 times 2 times 20 times 1 again. Then I'm going to divide by 3.78. Okay? Then I'm going to divide. I can divide by 1, divide by 1, divide by 1, and then divide by 3,600 seconds. And what you're left with is that 500 liters per hour is going to equal 5 and I'll round this up, did it again, 5.9 fluid ounces per second. And there's my answer. Okay? So these are two examples of complex conversions, converting both the numerator and denominator. Now the last type of complex conversion are these volume to area conversions, and then this last example here is a combination of what we just did and what we are about to do. And this is where it gets a little complicated and where you have to think a little bit. Okay? And this is going to be, I'm going to show you kind of the long way to do it. There's also a shorter way, but I'll kind of let you guys figure that out on your own. Okay? So, the first example we have here is going from 0.5 cubic meters, or meters cubed, to centimeters cubed. Okay? So this may look like a simple conversion, going from meters to centimeters. However, the cubed screws us up, changes the problem slightly. Okay? So, to understand this, let's think about what a meter cubed represents. Okay? Anything with a power, a meter cubed, or even a meter squared. Okay? What does that mean? Well, anything squared, or anything cubed, or anything with a power is itself times itself the number of times you have in that power. Okay, so a meter squared is a meter times a meter. That's a meter squared. Meter times a meter is meter squared. A meter cubed is a meter times a meter times a meter. Same thing applies to a centimeter cubed. So when I start off with 0.5 meters cubed, that's the same thing as saying 0.5 meters times meters times meters. Hence, here we have a volume conversion. Okay, we have a volume conversion because we have a length times a length times a length. Length times length times length is a volume. Now you can hopefully maybe see what's going to go on. We have not just 1 meter that we are converting, okay, but in order to go from meters cubed to centimeters cubed, I have to take each meter and convert that to a centimeter. So I am making the conversion of meters to centimeters not once, but 3 times. Okay, so what is our conversion from meters to centimeters? Well, if I set up my bracket, okay, I have to make this conversion 3 times. So, to get rid of the first meter, okay, I need to convert each of these meters to centimeters. So, I'm going to take 1 meter and convert it to centimeters. Again, to convert, hopefully you got this process down, we need to divide by meters. So that's going to cancel out one of the meters and convert it to centimeters. Now notice I still have a meter times a meter now times a centimeter. So I need to do that process 2 more times. I want to get rid of this meter. To do that, I need to divide by another meter, and to get the centimeters, I need to make that conversion. So I've gotten rid of 2, and then what I need to do is that one more time, 1 meter to 100 centimeters. And now notice all the meters are gone, and I am left with centimeter times a centimeter times a centimeter. Okay? And now what you have is 0.5 times 100 times 100 times 100. So notice how it's not just a simple conversion. You're actually doing that conversion 3 times. Okay, so that is 0.5 times 100 times 100 times 100. You need to plug that all into your calculator, and it's not going to give you 0.5 times 100 centimeters squared, but that's actually going to give you 500,000 centimeters squared. Okay, key thing here, volume. It's a volume expansion. Okay, same thing would apply to an area. So we're getting a slightly different answer, and this is one thing that people get commonly caught up with, is converting it just once. You actually need to convert it 3 times. Okay, again, we'll have more practice with this. Okay, another way to look at this, okay, is I did this same conversion 3 times. So another way to write this is if I take 0.5 cubic meters, I can do a simple conversion of meters to centimeters, but notice I did this conversion 3 times, and they're all multiplied by each other, and anything multiplied by each other is cubed. So, and the shorter way to write this is I can take this simple one-step conversion and then cube it. And if you think about mathematically, you're cubing the 100, you're cubing the centimeters, you're cubing the meters, you're cubing the 1. So you're taking the cube of all those things. Okay, and that's going to give you the same answer that we had up there of 500,000 cubic centimeters. Okay, so this is an example of a volume conversion. Alright, our very last problem of complex conversions is a combination of a numerator and denominator change as well as a volume or area conversion. So we are doing the first step that we did with complex conversions and the last one we just talked about, and combining them into one. So this example here, we have 50 pounds per square inch, pounds per square inch. Some of you may have heard of that unit before. And converting it into the same kind of thing but in different units, so kilogram per meter squared. So notice in both steps we are going from pounds to kilograms. So that is US to metric. And here in the denominator we're going from inches squared to meters squared. Now this one's complicated because we are going from both inches to meters, so that's US to metric, as well as the squared. So we are converting squared, so we are doing it more than just one time. We're actually doing it twice. The process, however, is the same. Okay, once you get the process down, this becomes relatively easy. So start with what I'm given. 50 pounds, and again, per square inch. The per stands for divided by, and then per square inch is every 1 square inch. So I have 1 square inch in the denominator. I'm going to do the metric or the matrix method this time. So I have 50 pounds per square inch. I'm going to start like we did before by just doing the numerator first, and then I'm going to work with the denominator. So the numerator, pounds. I want to go from pounds to kilograms. Okay? So looking at your chart, pounds is US, kilograms is metric. So I'm going to look at my US to metric conversions, and what I have is, if you look at pounds and kilograms, that's a unit of mass. And the only one we have for mass is 1 pound equals 0.45 kilograms. And that's the one I'm going to use. Again, to get rid of pounds, I need to place pounds in the denominator. I have it in a numerator there. And I want to go to kilograms. So I'm converting pounds to kilograms. And the conversion was 1 pound is 0.45 kilograms. So I have converted now from pounds to kilograms. And if you look at your numerator, voila, you're done up there. So the next step now is to go from inches squared to meters squared. Now here's where it gets a little tricky. Okay? Inches squared down here is the same thing as saying inches times inches. So I need to convert inches not once, but twice. And I need to convert inches both to meters squared. And then meters squared is meters times meters. So I need to do this whole process twice. So the first inch, I want to go from inch to meters. Again, that is US to metric. So looking at my conversions, I have, looking at inches, 1 inch equals 2.54 centimeters. So I'm going to use that one. Inches is in the denominator, so I need to cancel that out. I'm going to put inches down here and centimeters down, or inches in the numerator, centimeters down here in the denominator. Okay, and my conversion is that 1 inch is 2.54 centimeters. Okay, that gets rid of one of the inches. I need to do that again to get rid of the other inch. So 1 inch is 2.54 centimeters. So I'm doing this process twice because I need to get rid of each one. Okay. Now if you look at your units, you are left with kilograms in the numerator. Inches squared is now gone. And I am left with centimeters times centimeters in the denominator, or centimeters squared. Again, my goal is to get to meters squared. So I'm going to do that now. So each centimeter I need to convert to meters. I need to do that process again twice to get rid of each one. So centimeters is in the denominator to begin with, down here. So I need to get rid of it, so putting centimeters in the numerator. And I need to convert it to meters. So that conversion is 100 centimeters is 1 meter. Okay? So centimeters would cancel out, leaves with meter. If you check your units right now, you have centimeters times meters. These two units, even though they're metric, they don't correspond. Centimeter and meter are not the same thing. So I need to convert this other centimeter to meter. So I'm going to do the same process. 100 centimeters is 1 meter. Those cancel. And now what I'm left with is meter times meter. And just like math, like terms, you can now combine them. Meters times meters is simply meters squared. So if you look in the end, I have kilograms divided by meter, which is the same thing as saying kilograms per meter squared. Okay? And now to solve, you basically multiply the numerators, divide by all the denominators. So take out your calculator. You can start from the beginning, starting at 50. Take 50 times 0.45. Going all the way across, you can go times 1, times 1, times 100, times 100. That'll give you an answer. And then you want to divide by everything in the denominator. So you're dividing by 1, dividing by 1, dividing by 2.54, dividing by 2.54 again, then divide by 1, and what you get as an answer, 50 pounds per square inch, is the same thing as saying 34,000, oops, did it again, 34,875, I'll stop there, kilogram per meter squared. And there's your answer. So this problem I converted both numerator and denominator, and also did in this case an area conversion. So combining all these steps. And this concludes our lesson here on complex conversions. Your next lesson will be focused on dimensional analysis.